that feeling when you start a new document, with just that cursor blinking at you out of the overwhelming blankness of the page?
Do you mean the feeling of trying to get that blinking cursor to do something useful?
Yes, taunting me. Like I'm standing in front of an enormous block of marble with nothing but a spatula, and somehow I'm supposed to carve out a perfectly functioning software application.
Should we talk about coding habits that can help keep that giant block of marble from winning?
Those blocks of marble can be serious trouble.
That daunting feeling of facing a blank canvas can make it hard to start a new project.
Exactly. I have friends who felt intimidated writing even a single line of code because they weren't sure how to start, or were worried they would make mistakes.
Thinking about coding as a journey of constant learning might make it easier to embrace the process.
Right? Because if you are intimidated to write code, it makes it more difficult to learn. Consistent practice is so important. Write code, make errors, correct them, and practice more.
That's an important point. Making mistakes is not a sign of failure. It's a normal part of the iterative coding process for beginners, and even those who have been programming for years.
Yes! And I've heard people voice concerns that they weren't left-brain enough to understand code, and they were afraid that mistakes would make them seem unintelligent. But programming can be a creative experience. It doesn't have to just be logic and analytics.
Exactly. And when you practice regularly, it can help transform errors from something intimidating into vital learning opportunities.
A bug can be like a clue in a mystery novel, or a breadcrumb trail in a fable. It's just a puzzle piece that doesn't quite fit yet.
Maintaining that sense of curiosity isn't always easy, but it can help make errors less frustrating.
And if you keep practicing and solving puzzles, before you know it, the programming fundamentals have become more familiar.
Once you have that foundation, moving on to learn another programming language becomes much easier. Many core programming concepts, such as data types, structures, and how logic flows, transfer between languages.
Yes. The syntax is just a different dialect, but you already understand the basics.
We've identified two great habits already: practice often and learn by doing. But hold up. We've skipped past solving the blank canvas problem. Knowing how to handle mistakes doesn't automatically tell you how to start a new project.
Ah, right. You can't just stare at a blank screen, have a good attitude, and expect an app to magically appear without knowing what it is you want to make.
Exactly. Do you have an example of an app you want to build?
What about a to-do list app? That would be super helpful for me, and I wouldn't have to carry around all these scraps of paper with lists on them.
Okay, an application that helps us track things we need to do. That's a bit ambiguous though, right? We should be more specific.
This is bringing us back to the topic of our last discussion, computational thinking concepts.
Yes, you're right, it is. Let's start with decomposition. What is a to-do app actually made of? What are some of the parts?
One is show the tasks I need to do. I mean, obviously.
Good. That can be one of our components. It needs to show current tasks.
It also needs to let me add a new task. Oh, and a way to mark a task complete.
Perfect. We aren't just building an ambiguous app anymore. We are identifying smaller components that we can tackle one at a time. We are isolating challenges.
Yes. I can write out what the components should do in comments, and then later easily replace those with code. Oh, wait. I haven't written any actual code yet, but the page isn't blank anymore. It's filling up with comments.
Exactly. You've already started solving the problem. The computational thinking concept, decomposition, is part of the habit break big problems into small problems.
Having show tasks as the first step is helpful too, because I know how to print text to a screen. That's something I've done before.
Taking this one step at a time. That's another great habit. Make one change at a time, then test it. Add code that does one simple task, run it, and see if there are any errors. If there are, fix them.
Oh yeah, don't let hundreds of lines of code pile up before testing, or it might be hard to figure out exactly what is going wrong when tons of bugs pop up.
Right. Make one small change. Run it. Test it. Fix it. Save it. Repeat.
Wow, we've already uncovered 4 habits.
Yes. Practice often, learn by doing, break big problems into small problems, and make one change, then test it.
Okay, so continuing with the To-Do app, I already know a general idea of what is needed for the Add a New Task component. I've done that before with other code projects.
You recognized a pattern. You don't necessarily need the exact same code, but you already understand the general approach to solving this kind of problem. In computational thinking, after breaking the larger problem down with decomposition, we use pattern recognition to look at the smaller problems and ask, have I solved something similar before?
And after we add the ability to add a new task, we can add priorities to tasks, due dates, reminders, categories, color coding, recurring tasks, sharing task lists with team members.
Whoa, hold up. Do we need any of that to solve our original problem statement?
No, you are right. For the first version, I don't need to add all those features.
Let's use abstraction to focus on what matters most and create a simplified model. Something like a task that is either completed or not completed.
Right. To be a to-do app, that's what it really needs first. I need to start with the core functionality, the most important part.
Then we need an algorithm, which is just the step-by-step recipe to get from problem to solution.
How about Step 1. Me, the user, adds a task name and short description. Step 2. Save the task. Step 3. The task appears in my to-do list.
That's a great vision for the first version, and it will satisfy your original goal to create something that replaces the pieces of paper you use for lists.
Right. But wait, we need to explore something here. A lot of new programmers I know would stop there. Essentially, the app works, my job is done. Which, sounds like dun dun dun, a trap.
Good point, because you already know the development path isn't straightforward. Improving code is part of the process. Maybe it can be made more efficient, or even just easier to read. And that actually leads us to another great habit. Write code for people, not just computers. Aside from instructions, code is also a communication tool. Write code that is readable, understandable, and maintainable by others.
I feel seen. In the past, you've asked me about code I've written when I've named things in ways that didn't make sense to you.
Yes, if you use meaningful names for things, like variables and functions, you will get less requests from me to, please explain what this thing named Squishy Fish Monster is supposed to do.
Okay, that was once. And it was a slippery thing that only worked part of the time. And I didn't understand why it kept eating my data.
I understand that now, and we've figured out how to solve those problems. But my mind doesn't work like yours. You have a very different mental model of the world.
Yeah, I'm trying to get better at writing code that literally explains itself without needing a giant wall of comments attached to it.
That's important. The app itself doesn't care whether your variable is called T or task name, but the next person reading your code definitely will. Software development is often a team sport. If you are working with others, they will need to understand your logic and build upon it.
But if you were just working on a project by yourself, would you think, I know what T means, I don't need to spell it out?
Maybe. But if I come back to that project after a year, I don't think I will remember what T means. I'll have forgotten the context, and I'll have to figure out what I was thinking when I wrote it, which means wasted time and frustration.
Oh, that makes sense. Thinking about it now, if I go back to some of my earliest code files, I'm pretty sure I will find names like, this should be working, but it doesn't.
It's good that you saved your earlier projects. You can see how much progress you've made since starting to code.
I back up everything multiple times. I've had my heart broken after writing a massive chunk of beautiful code, forgetting to save, and my laptop randomly restarting or freezing.
That's exactly why we use version control on our collaborative work.
So we have a time machine that can magically take us back to an earlier version. Like a save point in a video game.
Right. And for me, it isn't just about data retention. I can take risks, try new algorithms, and push boundaries. Because I know that even if I completely obliterate the current version, I have a previous one that is safe.
Yes. The freedom to not worry about ruining something that was working.
That brings us to our sixth habit. Protect your progress, which can be thought of as three interconnected ideas. Saving protects your current changes. Version control preserves meaningful states and lets you track or restore changes. And backing up protects against losing files or even an entire repository.
Phew, it feels like we've covered a lot in this discussion. I also want to talk about some habits that can help someone get unstuck from a quicksand of errors. Oh, and the importance of keyboard shortcuts. But we should probably save those for another time.
Good idea. We've identified 6 useful habits, which is a great start. Let's recap them.
Let's see. The first habit we discussed was practice often. Coding is a lot like learning a musical instrument or a new language. You can't just study it. You have to put in consistent reps to progress.
Right, which overlaps with the second habit. Learn by doing. You can read about riding a bike all day, but you won't actually learn until you're pedaling, wobbling, and correcting your balance in real time. Code is similar. Actively writing, testing, and troubleshooting bugs builds understanding that reading alone can't. You learn faster, and you understand more deeply what the code is actually doing.
Then we talked about using computational thinking concepts for the third habit. Break big problems into small problems, especially decomposition, which breaks something big and ambiguous into more manageable components.
The fourth habit was make one change, then test it. We talked about taking one step at a time. Make one small change, run it, test it, fix it, save it, repeat.
Okay, that sounds like the start of a great song. Run it, test it, fix it, save it, repeat.
Another great idea. Open your new To-Do app and add it. The fifth habit we discussed was write code for people, not just computers. This is the empathetic approach of using clear, meaningful names for those who will read your work, including your future self.
And the sixth habit was how to secure our progress with a time machine so we can experiment fearlessly.
Exactly. Protect your progress, which includes saving early and saving often, using version control, and backing up important work.
With these habits, we have a lot of tools we can use to start sculpting and crafting with code when we are faced with the equivalent of a giant block of marble, the blinking cursor on a blank screen.
For those who joined us, keep practicing, stay curious, and make sure you celebrate your progress along the way.
Until next time.